Welcome back to another exciting episode of Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, I want to remind our amazing listeners that if you're enjoying our content, please rate us on your preferred podcast platform. Your support means the world to us. Today, we're continuing our journey through Season 1, Chapter 4, Decentralized Storage Systems. We'll be exploring the fascinating world of distributed storage principles. But first, let's kick things off with a quiz question for our listeners. Victor, would you like to do the honors?
Absolutely, Sheila. Here's a brain teaser for our listeners. What key advantage does distributed storage offer that traditional centralized storage systems struggle with? Is it A, increased data security, B, improved scalability, C, lower costs, or D, all of the above? Take a moment to think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a tricky one, Victor. I can already imagine our listeners pondering the options. While they're thinking, let's dive into our topic. Victor, could you start by explaining what exactly we mean by distributed storage?
Great question, Sheila. Distributed storage refers to a system where data is stored across multiple nodes or devices, often in different physical locations rather than on a single centralized server. The goal is to create a more resilient, scalable, and efficient storage solution.
That's interesting. So it's like spreading your eggs across multiple baskets instead of keeping them all in one, right? But I'm curious, what are the core principles that make distributed storage work?
Excellent analogy, Sheila. You're absolutely right. The core principles of distributed storage can be broken down into three main components: data distribution, replication, and redundancy. Data distribution involves spreading data across multiple nodes. Replication means creating copies of data on different nodes. And redundancy ensures that even if some nodes fail, the data remains accessible. Think of it like a library system. Instead of having all books in one central library, you have multiple branch libraries. Popular books, or critical data, are available in multiple branches, ensuring that if one branch is closed, you can still access the book elsewhere.
That makes a lot of sense, Victor. But it sounds like managing all of this distributed data could be quite challenging. Are there any significant trade-offs or issues that developers need to be aware of?
You've hit on a crucial point, Sheila. One of the biggest challenges in distributed storage is maintaining consistency across all nodes while ensuring high availability. This is often referred to as the cap theorem, which states that in a distributed system, you can only have 2 out of 3: consistency, availability, and partition tolerance. For instance, if you prioritize consistency and availability, your system might struggle when network partitions occur. On the other hand, if you focus on availability and partition tolerance, you might have to sacrifice some level of consistency.
Wow, that's quite a balancing act. It reminds me of trying to keep everyone happy at a family reunion. Sometimes you just can't please everyone at once. But let's dig a little deeper. How do real-world systems handle these trade-offs?
That's a great question, Sheila. In practice, many systems opt for what's called eventual consistency. This means that given enough time, all nodes will eventually have the same data, but there might be brief periods where they're out of sync. For example, Amazon's Dynamo storage system, which powers many of their services, uses this approach. It prioritizes availability over immediate consistency, which is crucial for a service that needs to be up 24/7.
That's fascinating, Victor. It seems like there's no one-size-fits-all solution. Speaking of real-world systems, how does distributed storage compare to traditional centralized storage? What are the main advantages?
You're absolutely right, Sheila. The advantages of distributed storage are significant. First, it offers improved scalability. As your data needs grow, you can simply add more nodes to the system. Second, it provides better fault tolerance. If one node fails, the data is still available on other nodes. Third, it can offer better performance, especially for users who are geographically distributed. Data can be stored closer to where it's needed, reducing latency. However, it's worth noting that distributed systems are generally more complex to set up and manage compared to centralized systems.
Those are some compelling advantages, Victor, but I can see how the complexity might be a challenge. Are there any common misunderstandings or pitfalls that developers should be aware of when working with distributed storage?
Absolutely, Sheila. One common misconception is that distributed storage automatically means better security. While it can improve data durability, it also introduces new security challenges, like securing data in transit between nodes. Another pitfall is underestimating the network requirements. Distributed systems rely heavily on network communication, so network issues can significantly impact performance. Lastly, many developers struggle with the eventual consistency model. It requires a different way of thinking about data integrity and can lead to bugs if not properly understood and handled.
Those are really important points, Victor. It sounds like developers need to be quite thoughtful when implementing distributed storage. Do you have any interesting facts or anecdotes about distributed storage systems?
Indeed I do, Sheila. Here's a mind-boggling fact. Google's distributed storage system, called Colossus, handles over 1 billion files per day. It's the backbone of Google's cloud services and can store exabytes of data. That's millions of terabytes. And here's a fun anecdote. The concept of distributed storage was partly inspired by how ant colonies store and distribute their food. Ants spread their food stores across multiple chambers to ensure that if one chamber is destroyed, the colony doesn't lose all its resources. Nature truly is an amazing source of inspiration for technology.
Wow, that's incredible, Victor. From ants to exabytes, distributed storage really is a fascinating field. Now, before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course, Sheila. The correct answer to our quiz question is D, all of the above. Distributed storage offers increased data security through redundancy, improved scalability by allowing easy addition of new nodes, and can potentially lower costs by using commodity hardware instead of expensive centralized systems.
Thank you, Victor. To summarize today's episode, we've learned that distributed storage is a system where data is spread across multiple nodes. Its core principles include data distribution, replication, and redundancy. While it offers significant advantages in scalability, fault tolerance, and performance, it also comes with challenges in maintaining consistency and managing complexity. Remember, listeners, when working with distributed storage, always consider the trade-offs between consistency, availability, and partition tolerance. And don't forget to account for network requirements and security considerations. That's all for today's episode. If you enjoyed this content, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you. Until next time, keep exploring the fascinating world of decentralized systems.